So hello everyone, hope everyone is fine. So in the previous class we have finished the ray optics, okay, and due to some lockdown or something else we were unable to continue the classes. So though after finishing of ray optics, I have told you guys earlier that in HS second year you will get optics based on two types of optics. One is ray optics, where the light will travel along a straight path. So in ray optics the light will travel along a straight path, but in wave optics the light will follow a wave path. So wave is basically what? A wave is basically a disturbance. Disturbance, what is disturbance? So let us try to understand. So what is wave optics, okay? So what ray optics told us? Ray optics says that light is basically consisting of particle, and each and every particle possesses energy, and this particle transfers energy from one medium to the another medium. For example, say this one is suppose the source from where you want to transfer light or say energy. So this one is suppose say the source, this is the source of light you can say, and this is suppose say the destination. Destination means the place to which you want to transfer energy or say light, okay? Source and this one is the destination. So if you want to transfer light from the source to the destination, then ray optics क्या कहते हैं हम लोगों को कि the particle will move from the source to the destination. So the particles, it will move from this position gradually to this position, okay? So the particles are moving and the particles will transfer energy, okay, to the destination. This is the fundamental of ray optics, okay? And ray optics tells that the particles moves in a straight line. So the particles transfer energy, and what is the name of each particle? Each particle is named as photon. So particles transfer energy, that is particles will physically move from the source to the destination. So the particles transfer energy, and what is the energy of each particle? Energy of each particle is h into nu. You got in chemistry in HS first year, okay? And each particle is known as photon, okay? So each particle is known as photon. But if we want to transfer energy, basically what we are transferring? We are transferring energy from source to the destination, and as per ray optics, that particles will transfer energy from source to the destination. Now suppose this one is source, okay? Suppose this one is water and this one is suppose the medium here. This is suppose say the medium. Medium is suppose say the water. हम लोगों ने इसको पानी ले लिया, ठीक है? And this one is suppose say the destination now. So the medium, just for understanding purpose, we have assumed that the medium is suppose water, okay? So if you disturb this source, suppose if you drop here a stone, this one is a suppose a stone, then what will happen? A wave will be created, and this one is suppose a piece of thermocol, okay? So if you drop here a piece of stone, then what will happen? A disturbance will be created, and the disturbance will travel like this, okay? So what will happen? If this is the thermocol here at this end, it will start vibrating. So it means अच्छा, क्या यहाँ पे water move कर रहा है? Whether the water is flowing from this end to the this end? No. Water is not moving from this end to the this end. Only the disturbance is traveling. Okay. So the medium is not propagating. According to this one, the particle will propagate. But here the particles are not moving. Here only the disturbance is traveling. If you drop a stone on the surface of water, then what will happen? A disturbance will be created, and the disturbance will move like this. The water will not flow. ओके तुम वहाँ पे देखो कि कोई एक पीस ऑफ पेपर या थर्मोकोल रख दो, तो तुमको ऐसा देन यू ड्रॉप ए स्टोन, यू विल फील दैट द थर्मोकोल इज, यू विल सी दैट द थर्मोकोल इज वाइब्रेटिंग लाइक दिस, ओके, बट द थर्मोकोल इज नॉट मूविंग एनीवेयर. सो इट मीन्स व्हाट? द वाटर इज नॉट मूविंग एनीवेयर. थर्मोकोल जो है वो किस पे था? पानी का ऊपर में था. अगर पानी मूव करता तो थर्मोकोल भी उस साइड में मूव करता, लेकिन थर्मोकोल तो मूव नहीं कर रहा है ना. Thermocol is simply vibrating at its own position. So what does it mean? The particles are not vibrating. The particles are simply transferring energy from one particle to the nearest particle. Okay. This phenomenon is known as wave optics, okay, where the particles will not move. So यहाँ पे particles are not moving, but they are simply transferring energy in the form of disturbance. So what we can say? We can say that the transfer of energy is taking place. Transfer of energy is taking place due to disturbance in the medium. Due to disturbance in the medium. Okay. So these 2 points, they are exactly opposite of each other. In ray optics, we have said that the particles are transferring energy, and here we are saying the particles are not moving. Simply the disturbance will move from source to the destination. Okay. So this is known as wave optics. So particles are not moving. So this theory, the ray optics का theory किसने दिया था? This is given by the famous scientist Newton. Okay, this theory was given by Newton, and the wave optics का जो theory था, this is given by Huygen. Okay, तो न्यूटन के बाद आया था ये हाइजन नाम का साइंटिस्ट. तो हाइजन को अभी क्या करना पड़ेगा? जो न्यूटन का थ्योरी था, न्यूटन्स का थ्योरी में क्या था कि एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन. ये तो यू ऑलरेडी नो ना, दैट द फ्रॉम लॉज ऑफ रिफ्लेक्शन यू नो दैट द एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन. that has to be established by Huygen, and fortunately Huygen established that angle of incidence is equal to angle of reflection in case of wave optics also. Okay, and from refraction what we can say? From refraction we can say that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is equal to the refractive index, which is also known as Ohm's law, which is also known as Snell's law. That is also verified by Huygen. Huygen in wave optics, he also showed that he also verified the the Snell's law of refraction. Okay, so later on scientist has to believe in both the theory. One is the ray optics where the particles will move, and another is the wave optics where there is no existence of particles. According to the wave optics, only the disturbance will travel from one position to the another position. तो साइंटिस्ट जो था उन लोगों के बीच में बहुत कंफ्यूजन आ गया कि वेदर लाइट इज ए पार्टिकल और वेदर लाइट इज ए डिस्टर्बेंस. और ये जो क्वेश्चन है ये अभी तक है, ठीक है. टिल नाउ इट इज नॉट डिस्कवर्ड दैट वेदर लाइट इज ए पार्टिकल और वेदर लाइट इज ए डिस्टर्बेंस. ओके, तो तुम लोग किसी को अगर नोबेल अवार्ड चाहिए तो तुम लोग इस पे रिसर्च कर सकते हो, ठीक है. तो बाद में एक साइंटिस्ट जो नाम था जिसका नाम डी ब्रॉयली ने क्या किया, दोनों को कंबाइन किया. रे ऑप्टिक्स मतलब पार्टिकल थ्योरी एंड वेव ऑप्टिक्स मतलब द डिस्टर्बेंस थ्योरी, दोनों को कंबाइन किया. एंड आफ्टर कंबाइनिंग ही सेड दैट लाइट इज कंसिस्टिंग ऑफ पार्टिकल बट इट फॉलोज ए वेव पाथ. तो उसने देखो कितना इंटेलिजेंट था, उसने खाली दोनों जो थ्योरी था दोनों को कंबाइन किया. और ये डी ब्रॉयली सेड दैट लाइट इज कंसिस्टिंग ऑफ पार्टिकल, दैट इज फ्रॉम न्यूटन, बट ही सेड दैट द लाइट पार्टिकल्स विल नॉट मूव इन ए स्ट्रेट पाथ, दे विल मूव इन द फॉर्म ऑफ ए वेव. मतलब light will move in the form of a wave, but the particles will move in the form of a wave. So that is known as de Broglie's dual nature or de Broglie's hypothesis. I think in chemistry in first year you got. इसका बाद एक chapter ही है जिसका नाम है dual nature of radiation and matter. There we will study. Okay, so this is the beginning. This is the beginning that we got ray optics, and now we will start wave optics. Now the question is how the waves are formed. How the waves are formed. Okay, to understand this, how the waves are formed, we have to understand the concept of wavefront. Okay, what we have to understand? We have to understand the concept of wavefront. Okay, so concept of wavefront. These are important, because these are the basics. If you do not know the basics, then it will be difficult for you कि कहाँ से आया ये wave optics. Okay, so the next topic that I said is your wave front. Okay, wave front means how the waves will be generated, that is given by the term called wavefront. Okay, how the waves are formed. Okay, तो suppose there is a medium, यहाँ पे मान लो ऐसा एक medium था, एक medium है, मान लो this is water, so here you have dropped a stone at this position. So this stone will behave as a primary source of wave. So from the top view you will observe a wave like this. This is the top view. Okay, it will be at the center. You have dropped, यहाँ पे पानी था, वहाँ पे हम लोगों ने एक स्टोन वहाँ पे फेंक दिया, तो एक पत्थर फेंकने के बाद वहाँ पे क्या होगा, a top view will like this, the primary wave will be formed. Okay, this is known as the primary source, this is known as the primary wave. Okay, so the concept of wavefront, okay. So this is the first one. The second one will look like this. Okay, the third one will look like this. So this is the top view. This is what? This is the source, or you can say primary source. This is known as the primary wavefront. This is known as the primary wavefront. Wavefront क्या है वो मैं बता रहा हूँ, ठीक है? And these are known as, these are called as secondary. These are known as secondary wavefront. Okay, अब देखो, this is the top view. Okay, this is the top view and these are the what, अभी मालूम चलेगा, ठीक है? अगर इस वेव का अगर हम लोग साइड व्यू देखते हैं तो इसका साइड व्यू देखने में कैसा होगा? The side view of the wave will look like this one. The side view of the wave, it will look like this one. Okay, so this circle is this particle. इसका phase कितना है? This is pi by 2. This is the first crest, so we will call this one is crest. Actually these all are crest. Okay, you are observing the crest. This is the crest, this is the crest, this is the crest. First crest, this one, this is the second one, this one is the third one. So what is the phase difference here? This is pi, 2 pi, so 2 pi plus pi by 2 is equal to what? This is 5 pi by 2. This one will be what? This is pi. Pi plus pi by 2 is equal to 3 pi by 2. But this is not the crest, this is the trough. Okay, so I will draw here a dotted circle. I will draw here a dotted circle. I will also draw here another dotted circle. Okay, so these dotted circles are representing the trough. Okay, acha, for this crest, what is the phase? Phase is pi by 2. For the second one, what is the phase? Phase is 5 pi by 2. For the third one, you will calculate. Okay, so these dotted lines, they are representing the trough, T-R-O-U-G-H. Okay, so is the diagram is clear to everyone? So this point is the crest, and here somewhere in this circle, this point is also the first crest. What is the phase angle? Phase angle is pi by 2. So you imagine, if we draw the locus of all the points vibrating in the phase angle pi by 2, this is what? This is a side view of the wave, na? So if we connect all the points which are vibrating at a phase angle of pi by 2, then what we will get? We will get the first crest. Okay, if we draw the locus of all the points vibrating at an angle of 5 pi by 2, then we will obtain the second crest. Okay, and these are what? These are nothing but wavefront. So what is the definition of wavefront? Wavefront is nothing but, it is the locus of all the points वाइब्रेटिंग इन द सेम फेज। जितना भी पार्टिकल एक कॉमन फेज में, अगर एक सेम फेज में वाइब्रेट कर रहा है, उसका अगर हम लोग लॉकस ड्रॉ करते हैं, देन द लॉकस विल गिव अस द वेव फ्रंट। ओके, सो व्हाट इज द डेफिनेशन ऑफ वेव फ्रंट? डेफिनेशन ऑफ वेव फ्रंट इज, definition of wavefront is, it is defined as the locus of locus of all the points in a medium vibrating in the same phase। Is the definition clear? देखो, the first जो wave है, wave front है, here all the points are vibrating in pi by 2, this one, okay, this is the point na, this is the wave. As you if we observe from the side, this is top view, not face, this is side view. So from the side view, it is clear that this point is nothing but somewhere in this wave front. Okay, so if you connect all the points vibrating in the same phase, then you will get the primary wave front. Okay, trough will not be seen from the top view. That is why we have drawn here a dotted circle. So this is the trough. So the first trough, this one, here the particles are vibrating at a phase angle of thrice pi by 2. Here the particles are vibrating at a phase angle of 5 pi by 2. So this is the definition and the concept of wavefront. Okay, this is the definition and what is basically the wavefront. So wavefront is basically the locus of all the points vibrating in the same phase. Remember, here the particles are vibrating in pi by 2, here 5 pi by 2, here it is 9 pi by 2. So try to understand what is wavefront. Okay, and in wave, since the particles does not move, what I have said, that in wave the particles will not move. That means wave is completely based on imagination. Ray optics easy tha, kyun? Because particles moves in a straight line. You simply draw straight line, you draw some geometry, you know the law of triangle, parallelogram, all these things, so it is easier for you. Ray optics easy tha, but in case of wave optics you have to imagine, because here we cannot draw any straight line, here we cannot draw anything. Okay, just one thing we can assume, that is about the wavefront. Okay, so how the wavefront is formed, this is given by Huygen. तो हाइजन ने हम लोगों को एक आइडिया दिया था कि हाउ दिस वेव्स विल बी फॉर्म. डेफिनेशन तो मालूम चल गया. नाउ द क्वेश्चन इज हाउ द वेव विल बी फॉर्म्ड. ओके, सो द नेक्स्ट क्वेश्चन इज formation of wavefront or Heisens Principle. So Heisens Principle is very important for your board exam. Okay, Heisens Principle. So now we will check that how the waves are formed and what is Heisens Principle. So our next topic is formation of wave front. Formation of wave front within bracket, this is Heisens Principle. Okay, this is about Heisens Principle. Okay, so how the wave will form. So what I have said earlier, that there will be a source. So from the source a disturbance will propagate in every direction. So if you draw a locus, you will get the first wave. So this is the first one. Okay, from this source the disturbance will propagate like this in every direction. So after some time, if you draw a locus, then you will get the first wave. This is known as primary wave or primary wavefront. I have already told you. Okay. So these things are not required. So this is the source. So this is the source. They are also, this is actually known as what? This is actually known as primary source. Okay. Now this is the primary wave. So according to Huygen, the first principle is every point on the primary wave, every point on the primary wavefront will behave like, they will behave like secondary sources. So पहले सोर्स कितना था? पहले सोर्स था एक, अभी इस वेव फ्रंट में जितना पॉइंट्स है ना, ऑल पॉइंट्स विल बिहेव लाइक ए सेकेंडरी सोर्स. सो अगर सोर्स ने एक वेव फ्रंट एमिट किया था, सो नाउ एवरी सोर्स विल एमिट देयर ओन वेव फ्रंट. ओके, सो व्हाट इज द सेकेंड वन? दैट एवरी secondary source will emit their own wavefront. अच्छा, these wavefronts will be small, will emit their own small wavefront. और small wavefront का नाम क्या है? Called as wavelets. They are known as wavelets. So small wavefront are known as wavelets. Okay, every secondary source will emit their own small wavefront called as wavelets. तो हम यहाँ पे अभी ड्रॉ करेंगे. What we will draw? We will draw the wavelets. So this is suppose the one wavelet. यहाँ पे मान लो एक source था. This is the another one. This is the another one. So these are the small wavefront. These are the small wavefront due to this source, this source, this source. Every point will behave like secondary source, na, on the primary wave. Okay. So these small circles, they are known as wavelets. Okay. They are known as wavelets. Done. Now, and the black colored, this one is known as primary wavefront. Okay. This is known as secondary source. Okay. Now these two are the first 2 points of Heisens principle. Third principle is that the common tangent drawn to the wavelets will give us the secondary wavefront and so on. मतलब ये प्रोसेस फिर से रिपीट होगा. सो व्हाट इज द कॉमन टेंजेंट? देखो इतना स्फेयर है, these all are what? These all are sphere, not circle. So what is the common tangent? Common tangent will be this one. This is the common tangent to all the sphere. Yes or no? So this is the common tangent to the sphere. मेरा थोड़ा इधर उधर हो गया, तुम लोग प्रॉपर डायग्राम ड्रॉ कर लेना यहाँ पे. Okay. This is the common tangent. Okay. So this is the secondary wavefront. This is the secondary wavefront. Now what will happen? Now the Heisens first principle will again repeat. मैंने क्या बोला? And so on. Now what will happen? Every point on this wavefront will behave like secondary sources and emit their own wavefront. So you will get some wavefront again like this. Okay, you will again obtain some wavefront like this. So what is the Heisens third principle? You have to draw a common tangent. So draw a common tangent connecting all the wavefront. Okay, ठीक है? So this black colored circle, they are what? They are nothing but the waves. So in this way, the wave is formed. ठीक है? This is the formation of wave or wavefront. Okay? This is the formation of wave with the help of wavefront. I think it is clear from the picture now that this is also known as secondary wavefront. Okay? Now same process will repeat. Some wavelets will be formed, and if you draw common tangent, you will get the next wavefront. Okay? So in this way, the wave propagates. ठीक है? First, this disturbance will be created, known as primary disturbance. It will create this one. So this is the secondary disturbance with respect to this one. Now it will create this disturbance, which will be secondary, and for this secondary, it will be primary. It will create another one that will be secondary. For that secondary, it will be primary, like this. And the wave will continue to move in all direction. Okay, so this is known as the formation of wave, or you can say the propagation of wave. Okay, with the help of wave front. Now we will see some this one, the different shape of wave front, which we will discuss in the next lesson. Okay, so this is all about wave front and Heisens principle. Shape of the wavefront for different sources will be discussed in the next class. Here this is point source, na? This primary source is nothing but a point source. So this is the wavefront for a point source only. But if there is a tube light is a cylindrical source. So what will be the wavefront, shape of the wavefront? Okay, so different wavefronts will be there that we will discuss in the next class.